Good morning. Dilika, working as an associate professor in the Department of Electrical and Electronics Engineering, R&D Engineering College. Today I am going to explain about the mathematical model of lightning strokes in assisting transitions. So, already we studied about the lightning process, how the lightning occurs, how the lightning discharges into the ground. And here, uh, when this lightning streamer occurs and it starts to discharge into the ground, first a leader stroke started, followed by the main stroke with considerable current flowing. For this discharge, we can draw the mathematical model. So, if we draw the mathematical model for this lightning stroke, which will have one source impedance as well as the impedance of the object. Here in this model actually, Z naught is nothing but the source impedance and I naught is nothing but the source current. So the source impedance and the source current which is due to lightning. Lightning is the source here. And here Z and I are nothing but the impedance of the object and the current through the object. And here V is the voltage across the object when the lightning discharge occurs. For this mathematical model, we have to derive the expression. Generally, we'll write the voltage expression as V is equal to I into Z. And if the lightning strikes an object of impedance Z, the voltage that will be built across an object. For that voltage only, here the expression is defined. And V is equal to, we can write the expression from this circuit, from this equivalent circuit. So we can apply current division rule. So here the total current into opposite resistance divided by total resistances. So what is the total current? Total current is I naught. I naught into its opposite resistance. So what is its opposite resistance? Is it not divided by total resistances? Is it plus is it not? So this is the formula to calculate V. Now here in this expression, we have to divide the entire expression by Z naught. So here we have Z I naught and this Z divided by this Z into Z naught divided by Z naught. So Z naught and Z naught get cancelled. So in the numerator, we'll get only Z. And in the denominator, if you divide this by Z naught, we'll get Z by Z naught plus Z naught by Z is nothing but 1. Therefore, the expression becomes V is equal to I naught into Z divided by Z naught. And here, we have the various values for Z and Z naught. So just I said Z naught is nothing but the source impedance and here the source impedance is nothing but lightning. So during this lightning, the value of source impedance that may vary from 1000 to 3000 ohms. And the value of the impedances of the different objects like transmission lines and overhead lines towers are also given here. For transmission line, the surge impedance that will be less than 500 ohms and for overhead lines, the impedance that varies from 300 to 500 ohms and for ground wires, the impedance varies between 100 to 150 ohms and for transmission towers, it varies from 10 to 50 ohms. And so if you calculate the value of Z by Z naught, normally it will be less than the value of 0.1. Since the ratio that will be very less so that it can be neglected. So if the value of Z by Z naught is neglected in this equation, therefore V is equal to I naught into Z. The value of V is equal to I naught into Z, where I naught is the mathematical model of lightning stroke current and Z is the surge impedance. The incidence of lightning strikes on the transmission lines and the substation are related to degree of thunderstorm activity and this thunderstorm activity which is based on thunderstorm days. So here there is a definition for thunderstorm days. It is defined as the number of days in a year when the thunder is heard or recorded in a particular location. This thunderstorm days, which is otherwise called as isochronic level. And this thunderstorm days, it cannot distinguish between the ground stroke as well as the cloud to cloud strokes. If a measure of ground flashover density Ng is obtained, then The number of ground flashovers can be computed from the thunderstorm level, and from the past records, the value of Ng can be calculated as 0.1 to 0.2 into thunderstorm days per strokes per kilometer square year. So this is the formula to calculate number of ground flashovers. And here, as per the records, this thunderstorm that will be reported between 5 and 15 in Britain, Europe, and Pacific West of North America, and it's in the range of 30 to 50 in central and eastern states of USA. A very higher level is reported from South Africa and South America, and there is no literature available for the different regions in India. But a value of 30 to 50 may be taken for the coastal areas and for the central parts of India. When a transmission line is nearer to the stroke channel, there will be a coupling between line and the stroke channel. During this time, the voltage at any length x is equal to n L can be computed from the equivalent circuit. So for different lengths, during this lightning process, the equivalent circuit has been drawn at x is equal to 0, x is equal to L, and x is equal to x, and x is equal to capital L. This is the equivalent circuit for different values of different distances of transmission line. And here, capital L is represented as length of the transmission line, and R0 and R1 is represented as the terminating resistances. L dash and C are the inductance and capacitance of transmission line per unit length. U dash of x comma t is the voltage developed at any distance x. Then I dash of x comma t is the current through the line at any distance x. Then E dash of x comma h comma t is the electric field in x direction at a height of h. Eg is the equivalent ground impedance. So by using this equivalent circuit, we can able to relate between the coupling of the transmission line as well as the lightning process. So this is the mathematical model for lightning.